This is question number 8 on the Quantum Electron Practice Quiz. We have ionization energies here, IE1, 2, 3. The key to understanding here is that this is the first electron removed, the easiest electron removed. That does not come from the first shell. That comes from the outermost shell. This is IE2. This is the second easiest to remove. You should see that it is much harder, much harder. It's 4,000 kilojoules per mole instead of 400. So this is a big difference, much harder. Exclamation point. We'll see why as we answer the question. So this says fill in the orbital designations, 1s, 2p, etc. to define what the numbers mean. So let's do that for sodium. Sodium's pretty easy to sing. 1s2, 2s2, 2p6, 3s1. That's 11 electrons, which is what sodium has. Okay, which is the easiest one to remove? Well, it's that 3s electron right there. So this is the 3s electron. Then the next electron has to come from an inner shell. The third shell has been emptied. So now we're taking a 2p electron. So that you can get by just writing the electron configuration and thinking you peel the orange from the outside. Take away the outermost electrons first. Second question, why is the IE2 so much higher? You've seen it is higher. We've already discussed that. In this case, the best diagram to draw is this one. There's a nucleus. Here's the first shell, innermost shell. Here's the next shell. And here's the third shell. This is the one that's easy to remove, because it's far from the nucleus and experiences less pull, less electrostatic force. Experiences less pull. Electrostatic force is what we're talking about here.
From the protons. Exclamation point.
IE2 is here. Pulls an electron from an inner shell, from the second shell. Second shell. Much closer to the nucleus, much stronger pull on the electrons.
Protons exert a stronger force. And therefore much more energy is needed.
There we go. So physics helps. Electrostatic forces are important. Knowing your atomic structure is also important, so you can figure out which electrons are in which orbitals and which shells.